When you guys are solving for logarithmic equations, you're going to want to keep in mind those properties that we learned about condensing and expanding. The reason we learn those is because they're going to help us with actually solving equations with logs in them. So one way of solving logs is canceling them out. So it says if b, x, and y are positive numbers and b isn't 1, then the log base b of x equals log base b of y if and only if x equals y. So what happens is when you guys have the same base, log base b, because they're the same, your argument or the big parts equal each other. If they're the same base and the equation is telling you they're equal, then x has to equal y. So it gives you an example. Log base 2 of x equals log base 2 of 7. Then x equals 7, so your solution for x would be 7. So let's look at an example. Let's look at number 7. So number 7 are the ones that we like, because when you have just a single log on each side, that's when you can cancel them out, like that example shows. So when we have log base 5 and log base 5, they can just cancel out, and we can just say, okay, when that's the case, 4x minus 7 then must equal x plus 5, and we can just solve it like a normal equation. So I'll subtract x. Add 7. 3x equals 12. And divide by 3 to get x equal to 4. So those are the ones we like, but we can only cancel out logs when they have exactly one log on each side. If one side has 2 logs and one side has 1, or just one of the sides has a log and the other one doesn't have any, you can't cancel them out. So you can only cancel them out if there's one on each side. So number 8 is an example where there's not a log on both sides. So the option here is not to cancel the log. The option here is to undo the log. So to undo the log, just like when we found inverses, we undid the log and made it into an exponential equation. We're going to do the same thing here. We're going to bring the base of the log over, and that gets rid of our log, leaving us with just 5x minus 1 equals 4 to the 2. Or 4 to the third power. So 4 to the third power is 64, and it just becomes a normal equation. Add your 1, and divide by 5, so x will be 13. So far we've learned that we can cancel the logs if there's one on each side, or we can undo the log. Now for number 9, we're actually going to have to use our properties for condensing and expanding, because if you look at this example, there are 2 logs on the right and 1 log on the left. So we can't just say, oh, they're all log base 4, cancel, cancel, cancel. It doesn't work that way. We need to condense the right side to make it 1 log, then we can cancel them out. So remember your properties. When we have addition, the 2 arguments that we have here, when we have addition, are going to multiply together. So we're going to keep the log base 4 on the right, but it will become x times x minus 2, because we're multiplying. So x times x minus 2 becomes x squared minus 2x. We still have log base 4 of 2x minus 3 on the left. Now that we have 1 log on each side, now we can cancel them out and get 2x minus 3 equals x squared minus 2x. Now, I'm hoping that if you remember back to Unit 1, whenever we have an x squared problem, that means it's a quadratic. And when we have a quadratic, before we can solve those, it needs to be in standard form, so it has to be equal to 0 before we can try and factor it or use the quadratic formula, whatever we might need to do here. So I'm going to move everything to the side where my x squared is. So I'm actually going to move both of these over to my right-hand side. And get 0 equals x squared minus 4x plus 3. So remember, we can always use a quadratic formula, but I think it's easiest to check and make sure that we can't try and at least factor it first. So if we're trying to factor 3, so what multiplies to get us 3 but adds to get us negative 4, it's going to be x minus 3 and x minus 1. So if we set both of those equal to 0, use our zero product property, x would be 3 or positive 1. Now what we have to check here, guys, is that when we plug this back in to our equations, we can't evaluate for negative values within a log. So if anything makes the inside of the parentheses a negative, it's not a solution. So I'm going to check. So you do want to check and make sure that they make the equation true, but you also have to check and make sure, like I said, that what's inside the parentheses does not become negative when you plug that value in. So when we checked 3, everything turned out fine, but when we checked 1, if you notice here, 2 times 1 minus 3 becomes negative 1, and 1 minus 2 is negative 1. So nothing that you can raise to a power is going to give you a negative value. That's why you can't evaluate for negatives inside those parentheses within a log. So if we're looking at the two answers we got, 1 is actually not going to be an answer, and the only answer we can have here is x equals 3. Now for number 10, there's not logs on both sides, so we're not going to use the method of canceling here. We are going to use the method of condensing to one log on the left and then undoing it like we did in number 8. So remember that when our sign is subtraction, the big part or the arguments are not going to multiply. When it's subtraction, they're going to divide. So this will become still log base 3, but it will be 9x over x minus 8, still equal to 4 on the right. So here's where we're going to undo the log by bringing the base of the log over and making it the base for our exponent. So that will make the log go away, and we'll have 9x over x minus 8 equals 3 to the 4th. So 9x divided by x minus 8 equals 81. And we're going to have to multiply by the denominator to get rid of this fraction. So multiply by x minus 8, technically over 1. Multiply by x minus 8, technically over 1. That will make that go away, and we'll be left with 9x equal to 81x minus 648. I did not know what that was off the top of my head. Although 80 times 8 would be 64, plus 8 times 1, or 640. And then we just solve it like a normal equation. So I'm going to subtract 81x, subtract 81x. And get negative 72x equals, that negative stays with that 648. And then just divide. So x will be positive 9. So you can cancel when there's one log on each side. Now you can make that happen by condensing what's on one side, or the other method is to just undo the log if there's a single log on one side. But again, if there's two, you'll have to use your properties to condense it to make it one. So why don't you guys go ahead and try the last one on that page.